Welcome to Project 8A, and in this lesson we're going to talk about slope. This is a continuation of what we've been doing thus far. 2 weeks ago we worked with auxiliary views. Last week we worked with true length of lines. This is just a continuation. We're trying to find slope. Now, the first thing that you must remember, to find slope you've got to come off of your horizontal plane. Alright? Now, we all know by looking at this, just ordinary top, front, and right side of a little small house with a hip roof. Okay, it's the easiest way to explain this, in my opinion. But again, the horizontal plane is always on your top view. Your front view is your frontal view, or frontal plane. I'm sorry, and the right side is your profile plane. So we understand that. So when we start trying to find slope, we've got to come off of that horizontal plane and go up to the line or even the rafter in this case to be able to find it. And for a good example, I want to show you this. This is the same thing we've got drawed in the multi-views. And again, this house is just a wireframe. It's setting on top, or actually, of course, the horizontal plane would be over on top of it, but it's setting parallel to the plane. So we can say, just to make it easy, this plane right here we'll say is our horizontal plane, just to make it real simple, because it's parallel with that glass box that runs over top of it. Now, if you look at it, what you're doing is, this is parallel to the horizontal plane, so that is accurate. I can come off of this up to the incline, and I can get my degree of slope from that. Okay? Again, this line, whatever you measure to, and of course this is just geometry, you can click on this and come down to this line. As long as they're parallel, it'll be the same degrees. The pitch doesn't change. So you have to come off that horizontal up to that incline, and that is your true degrees. Now, there's an important rule to this. When you're trying to find slope, you have to be able to find the true length of line. You can't just look at something and it's on an incline and be able to just go up there and snap a angular dimension and get it. No, you have to be able to see that part, that line or that rafter or whatever, in its true length of line, like we did last week. And there's two methods for that. But we're going here and let's make this a little bit more clear. Alright, let's say for instance I want to find out what the true length of this rafter is. Well, I can't. Not here, because it's foreshortened. Because it starts up here and it slopes as it goes down, right? So if I measured this right now, it would be short. It would be shorter than what it is in actual real life if I took that rafter off and measured it. When I come down here, this is the same rafter. In this view, it's foreshortened as well. It's going away from me as it runs off this off of the stud wall here up to the ridge line of that roof. It's run away from me, so it's foreshortened. However, when I come over to this side, this is that same line, and it's its true length. Y'all see that? If I were to take a measurement on that, that's the true length, and I could go to the hardware store and buy that, and it would be perfectly to the right size. Now, again, remember something. Up here is the horizontal plane. This is setting on, well, it's actually setting under the horizontal plane, but we're going to say, for instance, we're going to take our measurement because this line and this line here is perfectly horizontal to the horizontal plane. And if you look at it, let's say this is a horizontal plane. This is perfectly parallel to it. This is parallel to it. Okay? So I can actually go right now, take my angular measurement from here down to this line that's parallel with my horizontal plane, and I find out my slope is 37.7973 degrees. That's the slope of this rafter. It's 37.7973 degrees. Okay? Now let's look at another one. How about this one right here? Well, in this view it's foreshortened. Come over here, this is the same rafter. It's foreshortened, but over here it's actually showing the true length of it. So at this point, I can come over here and I can grab this, because this line's parallel to the horizontal plane. Remember, the horizontal is right on this line going away from us. So it's parallel, so I can actually click on that. There's my slope. 43.727 or 43.7297 degrees. That is your slope of that rafter. Now, so if I was designing this house, if I was a contractor trying to find out what size material, that would be easy. Those two would be easy. This one's always been our problem. Okay? You can't see it in its true length there. You can't see it in its true length there. And you can't see it in its true length there. So you remember how we did last week? We found the true length of the line. Now, it's easier to do this using your fold plane method when you're trying to find slope. So this is how I do it. First, you got to figure out what you're going to be able to take an angle off of the horizontal plane. Now, down here, I can find the true length of the line off of this point right here and come up, and I can find it right there. The only thing is, when I use this, just like an auxiliary view, and I turn it, when I turn it, like use this as a hinge line, and then turn it over, you're not going to be able to measure off the horizontal plane. Okay? This one we will be able to, because if you take this one and hinge this, it's going to fold it up, and you're going to be able to see, you're going to be able to use that horizontal line. And to do that, I want to use this one because in the horizontal plane, when I click on this one and I use this as my hinge line, like we're doing auxiliary view, and I fold it up, okay, I open that glass box up, I'm going to be able to see my horizontal plane and be able to measure off that horizontal plane up to that angle. And it'll make more sense in a minute. Down here, I can't do that. If I take this one, this is my primary auxiliary, and I fold off of it, I'm not going to be able to see my horizontal plane. Okay? So what I want to do at this point is I'm just going to throw me an offset on there. This is just what we did last week. Let me get a little bit more than that. Okay? Again, I always like to take my line. It's just a habit I've got. Just so everything meshes up good and perpendicular off of these lines. And then I come up here, line, I grab this point, come up here to perpendicular. Grab this one to perpendicular, just like that. Now, I've taken off this one and I've folded it over, okay? So now I can see, I'll be able to see my horizontal plane and then take the angle up to that true length of line here in just a second. To get the true length of line, I've got this point right here is this point to this point on the fold line, okay? So what I do is come up here, take my measurement from this point to this point, 0.43. So offset 0.43, enter. There's that one. And then I do another measurement from there to there, 1.273. Okay, just like that. And again, I'm going to change this, just really quickly change the color to red because this is my fold line. And all thing I have to do is just extend, make sure extend these lines down to where they touch. And again, when I bring this line on up in here, extend up to this one, this point right here was the smallest distance, so the line will start right there, and this was the longest distance, which should be at this point, which will be all the way over there to this line. So you come up here, you touch this line to this point. When we get this in here, this line right here, because remember, this is our primary auxiliary, and then it folds. This is our fold plane, and it folds out. This line right here, folks, will be your horizontal plane. Will represent that horizontal plane, and this is the true length of that line, and this is the angle that it's on. So to get your angular measurement, it would be from there to there, which we're getting 31.06. And this is to the hundredths position, but if you went back like we did earlier into our 3D wire frame, look at our 31.06. This is that horizontal plane line. It's parallel to the horizontal plane, and it just comes up there to that line that we're looking for, and this is our slope. So again, when you take and you fold something, this is the fold line. On the opposite side is the hinge, and then the hinge pulls out. So this is showing your horizontal plane, and this right here is that true length of line. Here's your actual slope. And just make sure when you're doing this, like for this point right here, again, like we said, comes up. There's our fold plane that we set up. Remember, when you come down to this front view and take this dimension off, 0.43, coming off this line, that's 0.43, so that's where you're going to start that line. Down here at this point is 1.273. That goes off of that fold plane line all the way back over here to this line, and it's from there to there, so that's where you end the line. So that's where you get your angle. Now we could take and hide all this stuff. So this is the true length of this line. So now this rafter, this right here, none of those we could see the true length, but now we can. This right here is the true length, and up to that horizontal plane is 31.06, and we were able to make sure it was and check it right here in this 3D wire frame. Again, this was representing the horizontal plane. This was that slope, so it's 31.0675, and we just say 31.06 degrees.